what we are going to do is we are going to pick different spots on the unit circle here and label each of these four things. The degrees, we'll start here. If this is 0 degrees, does it make sense that this is 90 degrees up here? 180, 270, and 0 can also be 360 degrees. And right beside it or right above it, we're going to do radians. So 0 and 360 is like having 0 and 2 pi. 180 degrees is pi radians. 90 degrees is pi over 2 radians. And 270 degrees is 3 pi over 2 radians. In the first chapter of this unit, I introduced you to 3 big ideas. One of those big ideas was that the points on the unit circle can be labeled cos theta comma sine theta. So if this is a unit circle, these are the points on our axes. So this is why this is called the axes family. And since the radius of the unit circle is 1, we can label these points as 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Now before we get to tangent, we're going to do some mental math. So Taryn's going to pick the first volunteer, and that volunteer is going to tell me what sine of 90 degrees is. So our big idea is that our coordinates on our unit circle are labeled cos comma sine. So if we can find out where 90 degrees is and look at that coordinate, we should be able to figure out what sine of 90 degrees is. It's equal to 1. Perfect. Santhia, pick someone to do cos of pi. So on our unit circle, the coordinates are cos comma sine. So if we can find pi radians on our unit circle and then look at the coordinate, the x coordinate will be cos of pi. Negative 1. Good. If I did sine of 270 degrees, what would I get? So Mariel, pick someone. Sydney? Did I say, what did I say? Sine of 270. Negative 1. So 270 is down here. Sine is the y coordinate on the unit circle. So sine of 270 is negative 1. Are we ready to make it a little bit more difficult? Or not yet? Yes? Okay. What is cos of negative 270 degrees? Shania. 0. So negative 270 degrees would go in this direction, be in the same place, coterminal with 90 degrees, and cos is the x-coordinate, which would be 0. What would be cos of 5 pi over 2? Arian. Again, I'm amping it up a little bit because 5 pi over 2 isn't listed on there. I want to find cos of 5 pi over 2. 0. So where is 5 pi over 2? Well, all the way around would be 2 pi, right? Which is 4 pi over 2. If you added another pi over 2 to that, you would get to 5 pi over 2. So 5 pi over 2 ends in the same place as pi over 2. It's coterminal with pi over 2. And so cos of 5 pi over 2 would be 0. And now we can start labeling the black ones and use our other big idea from the first chapter. If tangent is sine over cos, and what I'm going to write in each of these ones is tangent with the angle, so tan of 0 radians would be, what happens if I divide sine divided by cos? What do I get? 0 divided by 1. Tan of 0 will be 0. Can you see that tan of pi will be 0 over negative 1 will also be 0. But what happens when I try to do tan of 90 degrees or tan of pi over 2? You get an error because it would be 1 divided by 0. So we write that tan of pi over 2 is undefined. It's not possible. And same thing down here. Tan of 3 pi over 2 is undefined as well. This is our first family of 4 that now you can do all of those angles, sine, cos, and tan, without your calculator, just using the unit circle. So what we're going to do with the next 3 circles is introduce other angles that you can do without your calculator. So we can have more non-calculator trig questions. Yay! Yes, you will have to have this all memorized.